Welcome everyone. My name is Chris Camposano. I'm an associate director here at IHO. And welcome to the final talk of our monthly lecture series for the Lucy 50th anniversary. I appreciate, and I think we all appreciate, everyone who's been coming to these for the last 12 months as part of Lucy Fest. Speaking of which, last month was sort of one of the grand events in New York to wrap things up, coinciding with the month of her discovery. And today we'll hear from Yohannes Haile-Selassie on sort of what's been sort of since Lucy, right? What sort of discoveries, what have we been sort of standing on Lucy's shoulders now after 50 years? And so, as all of you know, Yohannes Haile-Selassie is the director here at the Institute of Human Origins. Prior to that, he spent almost 2 decades as the curator of physical anthropology at the Cleveland Museum of Natural History, which also has a very long history with Lucy, of course. Yohannes is a obviously prominent paleoanthropologist in our field. He is responsible for numerous important hominin finds. I think the statistics of the things he has found and their importance far exceeds random chance, that's for sure. Especially in the Middle Awash in the 90s in particular, and then for almost the last 20 years or so, the project he developed at Woranso-Mille, farther north in the Afar, where, having been there, I don't know how they find any fossils in their outcrops, which are about this high compared to Hadar, which are about 20 meters high. But somehow he is finding amazing specimens and important specimens throughout the Woranso-Mille area. So without further ado, again, thank you guys all for coming, and I will pass this on to Yohannes, who will be talking about Above the Shoulders of Lucy, how new discoveries and IHO's exciting future.
All right. Good evening. Thanks for coming. So it's sometimes good to be the last speaker, but not always. But it's good that I'm going to talk about just fossils, nothing else. So what you've heard so far from our research scientists in the last 10 talks covers like the diversity of all the research that we do here at IHO. Well, my talk today is going to be specifically on one of those subdisciplines that we deal with here at IHO. So paleoanthropology, basically, as Chris said, my work has been on fossil hominins for the last 30 some odd years now, since I was a grad student. But as Chris mentioned, in the last 20 years, I developed my own project in the Afar region of Ethiopia, and we've been making significant discoveries. So today I'm gonna talk about like Above the Shoulders of Lucy. Now, when we talk about new discoveries, we think about Lucy at some point 50 years ago being a new discovery. And that new discovery changed the way we understood human evolution for good, right? And in the last 50 years, a lot of progress have been made. So there has been significant discoveries as well. Some of them from my project, some others from Middle Awash, and a lot more specimens of Lucy's species from Hadar. So basically, when we say Lucy is really the most iconic specimen in paleoanthropology, there is a good reason, because she basically changed the way we understood our evolutionary history. And since Lucy, of course, all these discoveries that piled up also from Hadar kind of showed like the amount of diversity, the amount of variation that we can see in any single early human ancestor, right? So Lucy and her relatives from Hadar became like the benchmark of how we understand our earliest hominins. Now, you can go to any site in Africa. None of these sites has as many fossils as what we have at Hadar, right? Hadar has a very long history, almost 50 years, or 52 years, if we think about when they started. And when you talk about like 600-700 specimens from just a single site, that is unheard of. You don't see that kind of abundance from any of the sites. But when we talk about Lucy and her significance, it's always good to have a little bit of a historic background in terms of what did we know at that time like before the discovery of Lucy, right? In the 1960s, the number of fossils that we had of early hominins were mostly from South Africa. In South Africa, there are so many cave sites where researchers have been collecting fossils since the 1920s, like since the discovery of the Tong baby in 1924, right? But they've accumulated so many fossils from various cave sites in South Africa, but the age of these fossils didn't go beyond, at that time, 2.5, maximum of 3 million years. So the understanding was that these earliest human ancestors were as old as probably 2.5 to 3 million years. So nobody expected to find something as old as Lucy at that time. So here you see a slide. This is from 1967 by Vince Serich and Alan Wilson, when they were doing this immunological analysis of like relatedness, phylogeny. And at that time, all the fossil evidence they had for early hominids was younger than 3 million years, right? So when they did their analysis on serum albumin, they looked at the differences and similarities between chimps and humans, and they kind of came up with this phylogenetic tree where they thought that the last common ancestor that we shared with chimpanzees was only 5 million years old. Now that's like where we started. But of course, if you look at all this genetic analyses that happened in the 1980s, early 1980s, that split time was pushed to between 6 and 8 million years ago. So when Lucy was found, this was the background in terms of the split from the common ancestor we shared with chimpanzee. How about the fossil evidence? Now, the fossil evidence has clearly shown us that there are fossils from South Africa, but they don't go beyond 3 million years, and the earliest known species would be Australopithecus africanus. Now, Philip Tobias, who has done a lot of work in South Africa and on the hominins, he was really convinced that Australopithecus africanus was the ancestor of all later hominins. Now, look at the date. This is 1983, right? Lucy has already been found. But for Tobias, Lucy was just part of the Australopithecus africanus hypodyne. So he extended the time period all the way to close to 4 million years, but he has it as Australopithecus africanus. So basically, that was his way of not recognizing Australopithecus afarensis as a valid species. But you can see that that split that happens like two different lineages happened about somewhere around 2.5 million years ago. So that's what we knew at that time. And now, 1974, Lucy is found, okay? Lucy is found, and it's dated to 3.2 million years old, right? So now, the earliest hominin has passed that 3 million year record, right? But at the same time, this is like the most complete partial skeleton that hasn't been found anywhere in South Africa at that time. So she came with not only a lot of information, but also redefined how we understand about the earliest members of our evolutionary history. So basically, she became the oldest, but she also attracted a lot of public interest in human origins research. And this is where I think sometimes we think about, like, how do people actually communicate with the general public about these discoveries? And Don Johanson is really the best in terms of communicating science to the general public. And that's one of the reasons why Lucy became so important, so like a household name, that everybody knew who Lucy was, regardless of whether they understood what she means from an evolutionary perspective. But the fact that she was the most complete, the earliest human ancestor, that triggered a lot of interest in the general public. The other thing is, when she was found and she was the earliest, a lot of our colleagues, a lot of the researchers wanted to find specimens even older than Lucy. What that means is kind of triggered this interest in survey and exploration, right? And the first area that a lot of people wanted to go to was where Lucy was found, or nearby, right? So when you think about Ethiopia, which is where the Afar region is located today, you will see that in the last 50 years, more than 13 hominin species have been found in Ethiopia, in the Afar region and also in the Omo Basin. okay? But a lot of these are found from the Alpha Rift. So out of the 13 that are listed here, or 14, you will see that only 4 or 5 species are found from the Omo Basin, right? Everything else is found from the Alpha region. So when you think about the significance of the Alpha region in terms of human evolutionary history, you realize that there are at least 80% of the hominids that we know that have been found from the Alpha region, which means you look at this slide and you see that it goes all the way to about 6 million years, right? So at 6 million years, we have Ardipithecus cadabra, which is a species that I named in 2001, and Ardipithecus ramidus, and you go on all the way to modern humans, or at least ancestor of anatomically modern Homo sapiens in the form of Homo sapiens adultus. So when you look at this record, basically, we have in the Alpha region the entire fossil record of our evolutionary history. And it's really interesting because some of these time periods were sometimes open. There were no fossil evidence from some of these time horizons. And renewed research by what I did, for example, going to new areas and finding more fossils, kind of fills the gap that we had for a long time. So when you think about the Alpha Rift, this is to show you like where each of these sites are located. And you can see that there are at least 3 major paleoanthropological sites that are laid by IHO research scientists. Woranso-Mille is the one that I lead, and Lady Guerrero is Kay Reed, who's also our research scientist, and Chris Camposano is now the PI of the Hara project. So these 3 major projects in Ethiopia are actually run by researchers here at IHO, okay? So as Chris mentioned, I started working with Middle Awash, which is one of the best sites, even way more than Hadar, because Middle Awash has a whole continuous sequence of the last 6 million years of our evolutionary history. They have afarensis in Middle Awash as well, right? So this is like almost a kilometer thick sediments that we have in the Middle Awash. So Hadar is giving us like a window of time somewhere between 3 and 3.4 million years ago, which is also sampled not only at Middle Awash, but also at Woranso-Mille. So when we started work in 2004 at Woranso-Mille, of course, the sediments look very different from what you see at Hadar. There is a lot of faulting and there is a lot of cutting of sediments. So it was really difficult for us to actually piece together different sections at different places and come up with like a composite section where we can then talk about the fossils are coming from the section and that section. And this is what people like Chris do in the field. They do the geology, they do the stratigraphy, and they sample volcanogenic rocks for dating. And luckily, our geochronologists and other geologists have been really busy figuring out this stratigraphy, and they came up with what we now have as a composite section, which samples the time period between 3 and 4 million years. So this is really a very critical time period in our evolutionary history, not only because afarensis was right in the middle of it, but also at the very end is when we expect to see the earliest representatives of our own genus, the genus Homo. So basically, by looking at this hominids that we're finding from these sections, we can then start thinking about like what is the earliest occurrence of our genus Homo. Did it evolve from something like Australopithecus afarensis or Lucy species, or did it evolve from something else? And this is where understanding like how many species lived at the same time is going to be really important. Now, Lucy has been the queen. She was like the earliest ancestor of all hominids that came after 3 million years. But just imagine, she was found 50 years ago. In the last 50 years, the fossil record has doubled up. Even temporally, we now have like 6 million year old, 6.5 million year old hominids, right? Lucy is 3.2 million years. But that is the result of exploration and survey and discoveries that was really inspired by specimens like Lucy. So in the last 15 years, we have been able to recover at least 3 species that we have already named and 1 partial foot that we haven't named a species yet. So the first one that you see, the cranium, is about 3.8 million years old. And that is the only known cranium of a species known as Australopithecus anamensis, which is the ancestor of Lucy's species, Australopithecus afarensis. Then the second one is a maxilla and a jaw that we named as a new species, Australopithecus deuremida. I'll talk about that a little later. And we also have Australopithecus afarensis remains. Surprisingly enough, that partial skeleton that you see belongs to Australopithecus afarensis. It is 400,000 years older than Lucy. This is about 3.6 million years old. And basically, this is a large individual. And I remember from Joan's lecture, when she was talking about sexual dimorphism, she showed Kadanumu in a sketch with Lucy. And you can see how small Lucy was compared to Kadanumu, which is the name of this guy. Okay, I'll come back to that a little later on. And then we have the Burtele foot. What you see in this foot is, it doesn't look like your foot, does it? It looks like it has opposable big toe. Okay, it's like divergent. But this is not something that we would expect to see in Australopithecus afarensis or Lucy's species, right? So basically, if I told you that foot comes from a time period where Australopithecus afarensis, Lucy's species, was very abundant, you would say that, well, there must have been another species living at the same time. This cannot be Lucy, right, or her species. So all of these discoveries that we've been making, going all the way back to 3.8 million years ago, we've been trying to understand not only their taxonomic affinity, whether they are Australopithecus afarensis or something else, but we were also working on like understanding what it means in terms of how we think about famous specimens like Lucy, right? And there are also other famous specimens that were found later on. So here you see the temporal distribution of some of the specimens that we have, because we've been trying to understand this early hominins sequentially from older to younger deposits. And the green rectangle that you see there goes to about 3.6 to 3.8 million years ago. And from those sediments, we have recovered a number of specimens, some of which are clearly Australopithecus anamensis, Lucy's ancestor, but others could be afarensis. But they're mostly isolated teeth, except for some juvenile jaws that we have assigned to Australopithecus afarensis from about 3.6 million years ago. Most importantly, we have this partial skeleton. Now, when you look at this, it looks like it's not as complete as Lucy, especially when it doesn't have a head, right? But this specimen actually gave us a lot of new information that we didn't know about Lucy's species Australopithecus afarensis, particularly the shoulder girdle, right? Now, here you see a complete scapula. And if you look at the literature from the early 1980s, Lucy's scapula is so tiny that only the little joint surface, what we call the glenoid fossa, is preserved. And based on the orientation of that glenoid fossa, there has been a lot of functional interpretations that Lucy's species was arboreal because that joint faces more superiorly. Then here you have a complete scapula, which doesn't tell you the same story, because this is not like a chimpanzee. This is not like an arboreal primate scapula. And you combine that with the ribs that we have from this individual and try to reconstruct the rib cage, which previously, based on fragments of ribs associated with Lucy, they thought that afarensis had a rib cage that's funnel-shaped like chimpanzees, because chimpanzees were like the models that have been used to reconstruct the common ancestors we shared with chimpanzees. But what we learned from this individual is that those ribs that you see, they're like 7, 8, 9. They're very low, okay? And we can actually see like the curvature of those ribs. How much curved is it? And do you see any increase or decrease of curvature as you go down to infer funnel-shaped rib cage? So that's not what we saw in this one. So basically, it's not as barrel-shaped as in modern humans, but it was not funnel-shaped. So all of that information is what we learned from this individual, right? So it is a partial skeleton, but we named him Kadanumu. Now, Kadanumu means big man in the Afar, in the local Afar language. And Chris mentioned New York. At New York, when Don Johansson and Carl Zimmer had this conversation, when we finished, we came up, and one of our board members came to me and said, Yohannes, you guys got to find Larry. And what I told him was like, we have Larry, but we didn't call him Larry, so this is not Larry. This is Kadanumu. But basically, the amount of information that we got from this individual is something that we didn't learn from all the specimens that we have from Hadar. So at 3.6, we have Australopithecus afarensis. And then in 2009, we found a partial foot. Now, this was how it was found, in like 15 or 16 pieces. Then we put it all together. Then further analysis of the shape and arrangement of the foot was something like this. Okay. Basically, this was a foot that had opposable big toe. Now, we thought about this, well, this is only 3.4 to 3.3, and could it be Australopithecus afarensis? How much do we know about the foot morphology of Australopithecus afarensis? Luckily, we have some specimens of the foot of Australopithecus afarensis that we can come up with a composite foot for Australopithecus afarensis, and the assumption has always been like Australopithecus afarensis had a more human-like foot, right? But interestingly, even at 3.6 million years ago, at Laetoli in Tanzania, we have footprints. And we also have fossil specimens assigned to Australopithecus afarensis. So basically, if this was the morphology of the foot, or this is the footprint of the foot of Australopithecus afarensis, that Burtele foot could not have made this footprints. That's a simple argument that we can make. So basically, at this time, we know about another way older species called Ardipithecus ramidus. Now, Ardipithecus ramidus is about 4.4 million years old. And Ardipithecus ramidus had opposable big toe, like what you're seeing on this side. Okay? So when we found the Burtele foot, the first thought was, oh, this could be Ardipithecus ramidus, or Ardipithecus of some sort, right? So, but it's only 3.4, a million years younger than Ardipithecus ramidus. But that's okay. Some species have lived for more than 1 million years, or they have descendants after 1 million years. But we looked at the morphology really closely. The similarity is only the opposable big toe. When we look at the detailed morphology, there are fine details that are like that make this foot different from that of Ardipithecus ramidus. So we did not put it into Ardipithecus. We did not put it into Australopithecus. We just kept it as unknown until we find more specimens from that same locality where we can then make better comparisons. But in the end, this was published in Nature in 2012. But clearly, what we argued was like, this is a foot that shows that there were multiple ways of bipedal locomotion. It was not just one type. And this is, now that evidence is actually piling up like crazy, including from South Africa. So there was definitely some diversity in terms of how this early hominins moved on two legs. So that was why it was really significant and was published in Nature. In 2011, not far from where we found the Burtele foot, but slightly older, from about 3.5, we found these specimens, a maxilla, a lower jaw, and then two lower jaws, and then there was also a small piece of an upper jaw fragment. And those are like those two that you see. Those two are from the older section. They're about 3.55. And this one here is from a slightly higher section, right here. And the Burtele foot comes from right here. Okay. So it's in the same area, same section. But given how much we know about the variability of jaws in Australopithecus afarensis, we were really careful in terms of what characters we looked at to distinguish it from Australopithecus afarensis, right? So there are dental morphological features, mandibular morphological features, and that's what we piled up to actually talk about whether this is a different species or members of Australopithecus afarensis. So we mostly relied on the dental morphology and size, and what we noticed is that the teeth, particularly the premolars and the first molar and the canine, are really small. They plot outside the range of variation of Australopithecus afarensis in a lot of ways. And also, we see that the canine, the upper canine, is more primitive, meaning it is not incisor form. It's not like an incisor like what we see in afarensis. It's more like an ape. It's like triangular. It's really cone-shaped, right? And that's really an important character that we use to distinguish it from Australopithecus afarensis. We looked at the enamel thickness of the molars, which also fell within the range of another group of hominins called Paranthropus, the robust lineage. They were really thick. And that is not something that we were able to see in Australopithecus afarensis. And finally, the overall shape of the jaw was also reminiscent of what we see in the robust lineage and not in Australopithecus afarensis. So for us, these were significant distinguishing traits from Australopithecus afarensis, and we designated it to a new species called Australopithecus deiromeda. Okay. Now, a lot of people haven't been able to even name the name yet, but they will get used to it at some point, I hope. So here is like new discoveries from a new site, and clearly a lot of our colleagues will still ask, is Australopithecus deiromeda different from Australopithecus afarensis? Well, yeah, the sample size is really small, and we still need to find more and justify that this species is valid, right? And they also ask about, like, is the Burtele foot different from the foot of Australopithecus afarensis? I mean, by now, you should be convinced that it is different, right? So the take-home point here is, if it is different, we have another hominin, no matter what it is, that lived at the same time as Lucy's species. Right? So you have at least two different species. And this is where we talk about like hominin diversity, how many species lived at the same time. This is something that you wouldn't have talked about for anything older than 3 million years, even in the 80s, or even early in the 90s, right? So we try to document all these hominins that we're finding in a temporal context. And as you can see here, Australopithecus afarensis from Woranso-Mille is known from about 3.6 million years ago all the way to 3.2 million years ago. So basically, the older Australopithecus afarensis that we have from Woranso-Mille is older than the oldest at Hadar, where Lucy was found. Then within this time period, we have the remains of Australopithecus deiromeda. So that blue box that you see is the time range for Australopithecus deiromeda. And then you have the Burtele foot, which is also right in that time period. Okay, so this is the best evidence that you can present to argue that Lucy was not alone, or her species was not alone between 3 million and 3.6 million years ago. So scientifically, this is what the fossil evidence tells us, right? And this is the progress we make in terms of our knowledge and in terms of our discoveries and in our interpretations. And really, this is something that I would say this is probably the most convincing evidence that we have to show that there were multiple hominid species during the mid-Pliocene. Now, this was not the first time to actually show diversity during Lucy's time. It goes back as early as 1995. Now, in 1995, Michel Brunet and his colleagues named a new species called Australopithecus bahar-al-Ghazali. And this is really surprising because this specimen that they found that you're seeing on the left side comes from Corotoro, which is really unusual because all the hominins that we have, early hominins that we have, were from right here in this corridor here. And now you are like right in the center of Africa, in Central Africa, in Chad. That is about 2,500 kilometers from the main area here, okay? And all they had was that jaw, but they named a new species, and they called it Australopithecus bahar-al-Ghazali. So that is when this idea of multiple hominid species during the Pliocene started. Now, that specimen was dismissed as this is just a geographic variant of Australopithecus afarensis, right? But clearly they insisted that this is different, and it had different environment, it lived in a different environment, but still today, this is still questioned like as maybe not a valid species. Another one is something called Kenyanthropus pladiops. This is from 2001. Kenyanthropus pladiops is not only a new species, but it's also a new genus, different from Australopithecus. So when they found this, they described it as different from Australopithecus afarensis in terms of its facial morphology, and it had more vertical face, which means it would be more related to the lineage of Homo than Australopithecus is. So it brought up this new phylogenetic questions in terms of what is the place of afarensis in our evolutionary history. If Kenyanthropus pladiops at 3.5, 3.3 million years ago is the ancestor of the genus Homo, then what is the role of Australopithecus afarensis, right? So those questions had already come up as early as 1995 and 2001. So all the discoveries from Woranso-Mille were really surprising because that came from right next door, right, from Hadar. It was only 30 miles away from where Lucy was found. So in terms of the phylogenetic relationships, you go back to the 1990s. Before 1990s, this is all we had, which means Australopithecus afarensis, represented here by Lucy, right, is the earliest. So her species would be the best candidate to give rise to the other hominid species that came later. But now, we have 20-some odd hominins recognized in the fossil record. And you can see that some of them are as old as 6.57 million years, which is twice as old as Lucy's species. But this is what happens when you go out and discover more fossils. This is the significance of survey and exploration to new areas that we haven't been to, right? Because it's all about finding and learning more. And we have learned more in the last 50 years since the discovery of Lucy. So what is really clear right now is this time period between 3.6 and 3.3 million years ago, there were multiple hominid species running around. What you're seeing here is at least 4 or even 5. But for us, especially working at Woranso-Mille, we're not worried about how many species were there. Or did Lucy coexist with other species or something? Our question is mostly like focused now on what is coming out of Woranso-Mille, okay? Because I mentioned to you that we have 3 species, maybe 3, maybe 2, that come from the same horizon at Woranso-Mille, but at Hadar we have only 1 species, which is Australopithecus afarensis. Okay. So our interest right now is why do we have multiple hominid species at Woranso-Mille and only 1 species at Hadar, which is only 30 miles away from Woranso-Mille, right? It's not that far, right? So in addition to that, those species that we have from Woranso-Mille, they're not far from each other either. What you're seeing here is like Australopithecus deiremida specimens right here. This is Australopithecus afarensis. This is also afarensis. This is slightly older. This is about 3.6. But these guys here are between 3.3 and 3.5. This is 3.4, and that's 3.3. So basically, they're all there, right? So for us, it's like, how did they manage to coexist in such close proximity, right? So we started with hominid diversity, right? We tried to answer that question, but by finding this close to each other, we have yet another research question, which is how did they manage to coexist in such geographic proximity? And this is where you need like a collaborative effort. It's not like just a paleoanthropologist going out there and doing this. So we have a project known as the KIC project where we brought like, about 35 scientists together to answer this question. That we have geochronologists, we have geologists, we have paleoecologists, we have paleoanthropologists and paleontologists, all trying to work together to answer that question. Here you go, collaboration. That's what John was talking about. It's not unique to us. Other primates also collaborate, but this is like what we are trying to do now. So instead of going further, I can talk for like the next 2 hours, but I just want to conclude by saying that one, Lucy species is still the best species that we know, but afarensis was not alone. There were other species living around at the same time. But we also can say that given the fossil evidence that we see, Woranso-Mille is probably the best site to give us the best evidence for the presence of more than one Homo species during the Middle Pliocene. And finally, this is the most important point, right? Is Australopithecus afarensis still ancestral to our lineage, right? Now, all of the other taxa that I told you about, we know them from only a few specimens. We don't really know them much as we know Australopithecus afarensis. So afarensis still remains to be the best candidate to be the ancestor of other hominids that came after 3 million years. But clearly, what we have known in 1974 versus what we know today is different. What we know today could be very different from 10 years from now, 5 years from now, as we find more fossils, right? So this is what I have for you. And before I finish my talk, I just want to say that having heard to all of these talks by our research scientists, there were about 9 talks before me. And for people who have watched those lectures, they realize the depth and breadth of the research that we do at IHO. We've talked about collaboration, we talked about cognition, we talked about gene-culture coevolution, we talked about behavior, how we study modern primates to understand the behavior of our earliest ancestors, how we go out to the field and find fossils, how we talk about the origin of anatomic model Homo sapiens based on the evidence that's coming out of South Africa. So all of that is clearly a manifestation of what IHO is all about, right? And basically, I think it was Tom who showed a slide similar to this one. And you look at this, which is also on our website, okay? This is the diversity of research that we do here at IHO, right? And this is probably the best time to give credit to my predecessor, the late Bill Kimball, who had a vision to make IHO multi- and transdisciplinary institute that has a lot of researchers in it and work toward the same goal. And I think that his vision is now bearing fruits the way I see it, and I'm really extremely happy with that. And we will continue doing the same thing, and we will make sure that IHO is not just about the research that we do within the academics, but as IHO, we also have a very significant portion, which is public outreach. Now, our work could be like very exciting to us individually, but if we make it relevant to other people, if we can explain our research and our results to other people in a layperson's language and make them feel that they're part of it, this is also something that relates to them, right? Because I talked about fossil hominids from 3.5 million years ago. How many of you felt like I connected with you? Oh, that's exciting. That's really cool, right? But what we need is our science has to be more meaningful than that, which means you tell your research and your results to somebody in a way that they can connect to it. And I think this is something that we're starting now, and we have so many opportunities to do that, and IHO's future will be really significant if we can connect with our communities, if we can convey the message in a way that people can understand it, because this one world that we have, we all know what's going on. And when we say we are researchers who connect the deep past with our future, that's a very strong statement. And we have to live to those words, right? And the only way we can do that is by actually making sure that every opportunity that we have, we connect that science to the people that we talk to in a meaningful way, in a way that they feel included, right? That's I think, the future of IHO that I would like to see. And I'm really excited by everything that our researchers have done while we celebrated Lucy 50 and Dawn in the last 12 months. And that is the kind of spirit that we would like to continue moving forward, right? But we would just expand it to bring in even more people and truly say that we are connecting the past with our global future. Thank you so much.